the greenhouse effect, and feedback loops. And we've even talked about El Nino, so I want to just finish up this vocab. And once we're done talking El Nino, we can finally talk about the future of climate, which I think is the part that interests my students the most, actually. Today may be one of the days when you have the most content that's relevant to the rest of your life. My students are usually interested in this conversation. But I got to finish a couple bits of vocab. So on Tuesday, we talked about what normally happens and what El Nino is, correct? Yes or no?
Yes.
Hope Dalton, were you saying no? You were saying Did we talk about ENSO? El Nino Southerly Oscillation? Did we talk about La Nina? Which is the unusual cooling of the surface of the Pacific? Did we talk about the Pacific Decadal Oscillation, the PDO? James Bell, put your cell phone on top of the solar house next to you. And did I tell you this word? Aha! It is Modoki, or Modoki. And I don't speak Japanese, and I've heard conflicting pronunciations from Japanese speakers. Modoki or Modoki? So, I do not speak Japanese, as you might have guessed. I don't know if it's Modoki or Modoki, the pronunciation eludes me, but I can tell you a few things. It means like, comme si, comme ça, neither here nor there, más o menos. Like, so-so, wiffly-waffly. It's a year that starts El Nino, but then changes halfway. Or does not start El Nino and then becomes an El Nino halfway.
Is that what we have right now?
And that seems to be what we're in now. Our part of the ocean is definitely Modoki. I just haven't heard if that's across the entire Pacific Ocean.
So
The Japanese named the phenomenon because I think you understand that they have a very personal relationship with the ocean. It's a teeny little island surrounded by a relatively hostile ocean environment. So the Japanese watch the ocean more carefully than pretty much any other nation. They have like all the leading ocean science people. And they noticed a few years ago records that showed didn't start discretely El Nino and then El Nino developed, or vice versa, started El Nino and then it collapsed. They've even found some years that start El Nino and end La Nina. They go from one extreme to the other. And the only reason this might be significant is early research by Japanese oceanographers suggests that Modoki years are becoming much more common. And a lot of people argue that, the IBX cell phone, that this oscillation is being disrupted by climate change. A lot of people feel that the Pacific Ocean may get sort of increasingly chaotic as our climate changes, which is probably a reasonable guess even if you didn't have the data.
So this year is a collapse year.
So who's on what now?
So this year is like a El Nino collapse Modoki year? Or?
Yeah, I think so. Although in our part of the ocean, like in many parts of the ocean it looked like it was El Nino and then it didn't, and in our part of the ocean it looked like it wasn't and then it is. All right. So what I want to talk about now is number 24, which is actually one of my absolute favorite study goals, and my students usually talk to me more about this one than anything else all year. Number 24. And for students who did your homework, you'll notice my list is not the one you got out of your book. My list is pretty different. I don't want to give you any predictions about when something will happen in a single place. I want to keep my predictions really clean and simple. It's really hard to predict the future. Climate systems are really complicated. The data keeps changing, and the variables keep changing. So anybody who tells you on 2017 the temperature is going to be so-and-so, that's kind of a risky maneuver, and I don't want to give you any like specific detailed predictions. I want to just talk about the general things that are pretty darn indisputable. Like, given that climate is changing, and given that we know that rate of change is unprecedented, what can we say? Number one, global weather patterns are all changing. If I told you to circle the places that are hotter than average for the last decade or colder than average for the last decade, you'd circle the whole map. In other words, no place has stayed average. And if I told you to circle the wettest or the driest that they've been in the last 115, you would pretty much be circling almost the entire map. In other words, weather systems are destabilizing. Abnormal weather is increasingly common. There's a lot of ways to say this. Extreme weather events are becoming more likely. There are multiple 100-year storms per 100 years now. Many places just had the worst heat wave or the worst cold snap on record. It would be really shocking if somebody said, you know, this was a really normal year. Like, that was just plain old average. Like, that doesn't happen. And statistically, most years should be roughly average years. Number two. The rate of that change is devastating for biodiversity. We don't really find many opportunities for adaptation because things are changing too fast. Think of what you know about natural selection and evolution. Natural selection acts on existing variation, and you know, winners and losers. The tallest individual can reach the most abundant food up high, or the shortest can hide best in the cave away from the predator. But imagine if all of a sudden I put the food out of your reach, you cannot evolve to reach it. You would just simply starve. As our climate shifts so quickly, there is not a member of the population who can win. They're just all losers. The rate of change in climate is outpacing the rate of change in evolution. And I think you'll remember from Unit 2 or 3 that if species didn't all depend on each other, that wouldn't be a big deal. But the really sketchy part is this one. When pieces of the food web are affected independently. So the ducks, instead of adapting, they might adjust by merely shifting their habitat, but if their food source has shifted to a separate habitat, then neither of them will see each other. Flowers don't have their pollinators, birds don't have their habitat tree. This is all number 2. Think of how devastating it is for ecosystems, that things are changing so quickly. When we look in our fossil record in the history of life, all the mass extinctions were all caused by rapid climate change. Number 3. Agriculture is pretty maxed out already, and what happens when agricultural zones don't work anymore? Like, what if the corn belt gets too hot or too cold or too wet or too dry? I'm not sure that everybody understands how maxed out our global food production is. We're already struggling with water, already struggling with nutrient availability, already struggling with soil loss, topsoil loss. We already have less food being produced per human for the first time in human history. We already have rapid population growth. We've already maxed out our food production. And now here's the other problem, the climate change problem. We found the good places to grow food. The combo of rainfall, temperature, and soil, that's where we make food now. The combo of rainfall, temperature, and soil, right? But if those temperature and rainfall zones don't line up anymore, or what if the perfect weather zone for corn shifts to like the Chihuahua Desert? That soil is going to take, a couple of million years to catch up. And so the really scary proposition is we've already seen, you talk to farmers and whatever they used to grow is getting tricky. They got to try something new. Every farmer I know, they're all making changes to what they grow. They're like, I had to give up on the peaches, now I'm growing pluots, or I had to give up on the strawberries, now I'm growing lettuce. Like, there's a lot of wiggle room. I'm not saying we're all going to starve. By the way, we're Americans, we'll starve last. But we do know that agricultural productivity will probably decline. Global food supplies are definitely going to go down. It's hard to deny that. Everybody's already betting on that. That's a bet that's already been laid. Number 4. Does anybody know the source of most of the world's drinking water? I'll give you a hint. It's not rain and it's not groundwater. And it's definitely not desal. Lakes, let's call that rain. More than 1/3 of humanity gets water from just a single region of glaciers. And everybody knows that glaciers are melting. The good news is that most years are just above or just below glacier average. So far in human history, you get a couple of hot years, then you'll get a couple of cold years, and you'll build up a bunch of snow in the glacier again. So most of the glaciers, they can take a little heating and cooling because they just it's like a giant savings account. Yeah, all right, I went big this year, but we're going to make some big deposits soon. That's how glaciers work. Bummer is not really anymore. No, they're just melting. Globally, there are very few, I think 2, growing glaciers. And many glaciers are disappearing fast, including imagine the tragedy of this. The glacier that my boy is named after. It's no longer a glacier. My boy's namesake glacier was downgraded to a seasonal snowfield before he turned 3. Okay, so I kind of named him after a small glacier. That was my beat. But this is really bad if you live in India, Southeast Asia, or China. Not like anybody lives there or anything. But the Himalayas have quite a bit of water storage. BT dubs, so do a whole lot of people that drink out of the Andes. There is probably not as much water in the European glaciers, and up here there's just not enough people who rely on it. But that is a big shift in water supply. You can move food to where the people are. You can't really move water that far. Number 5. This is the one that keeps me up at night. I've got 1,000 little details about this one, so I'm going to rattle a lot. But number 5 is the disease thing. I'm obsessed with disease issues. I've told you before, I am, like, for me, the scariest apocalypse is a disease. Doesn't do you any good to worry about it, but there's a whole lot of reasons why many, many scientists, including the World Health Organization and the United Nations, fear the single deadliest consequence of climate change will be disease. I have so many details that we don't have the time to talk about all of them. Multiple books have been written about this. I encourage you to keep an eye on it, but let me try some of the basics, just basics. For one thing, hungrier and thirstier humans make better patients. In other words, we know that human physical stress will increase. Physical stress. Not emotional, but like your body. Yeah.
Is it affected?
I mean, it's the napkin talking about disease. How about that? We also know that as biodiversity shifts around the planet, so do diseases. It's called the vector effect. You know, when animals move, so do the diseases that they carry. Apparently the Black Plague was not spread by rats. And I know it's the fleas, but it was not spread by the fleas living on rats. Do you guys hear this? Because rats have remained roughly consistent. It's not like the rats declined after the Black Plague went away. You know what did decline? What was a rare fluke shift in mammal species? Asian gerbils.
Gerbils.
Yeah, they're great gerbils. I knew it was Asia's fault, yeah.
It always is.
It always is. Okay. I have an interesting example of this. Keep in mind that a lot of times species range is only limited by weather extremes. So, you know, the mosquito doesn't live there because every winter it gets so cold that all the mosquitoes freeze, so you can't get mosquitoes in that climate zone. Or it's just a little bit too dry, so they'll have a generation that doesn't find puddles to lay eggs. Little changes can make habitat accessible to species where it wasn't accessible in the past. So does anybody know, have any of you heard of West Nile virus? I've got a great story for you. About 6 or 7 years ago, there was no West Nile virus in the Americas. It didn't happen. Apparently, we've followed the genetics now. Some freaking crow had been infected by a mosquito, came to New York, and we believe in Central Park. And maybe it was a duck. Maybe it was a duck. Can't remember if it was a crow or a duck now. Some bird. Came to Central Park. Mosquito fed on this bird, and when the mosquito put its eggs in the water, the virus could survive in the water long enough to reach that critical mass where enough mosquitoes spread it around that the disease becomes an American possibility. It was because of changing water temperature in the ponds of Central Park in New York, we think. That disease, over a few years, spreads throughout the eastern seaboard, down to Texas, over a few years reaches SoCal, and my parents' neighbor was the first case in California a couple of years ago. The first death from West Nile virus in California happened in Irvine a few years ago. My mom and dad went to the funeral because it was a neighbor. This is exactly how diseases shift with climate. It's that little tipping point for one of the vectors that just barely, just a little shift in populations, all of a sudden, huge avalanche of disease transmission through new land masses. And you know that's really scary because societies don't adapt that quickly. If Better's had the flu, I could be like, girl, you're too sick, go home. But if she had malaria, I personally don't recognize malaria. If her neighbor says, yo, we got malaria on the block, take out your mosquito net, she might not have a mosquito net at home. If her family physician is the first person to for the first time, prescribing a malaria medication, he might not know to keep an eye open for that sensitive interaction with her, whatever, antidepressants or uppers or whatever kids take. Societies take a long time to deal with diseases. So we believe that diseases will spread, people will spread them, and so will biodiversity. And that's the one that I could talk about this for weeks. If you guys are ever interested, we can talk a lot. Imagine surface water gets hotter, so diseases survive outside your body longer. All right, number six. Sea level rises. Early predictions of sea level rise were a little bit pessimistic, but future predictions, there's no good option. Most people consider 3 feet by the end of the century, a yard, to be a fairly modest guess. Some people say as much as 30 feet of sea level rise. I'm not going to pick a horse in this race. 3 feet's bad enough.
That wouldn't impact us in our lifetime, though, would it?
Well, this is exactly where I can explain to you how it would. The one thing we got to be clear, don't worry, you will never be chased down by rising sea level. You'll not have to outrun it. It won't mess up your Star Wars figure collection. You'll be okay. So in the sense that you're not going to get your feet wet, right, no worries. Yeah, that's cool. But there is something that you guys have to keep in mind. The sea level rise is not what you're thinking. For one thing, it could affect your groundwater supplies. Think of what that would do to Santa Barbara's groundwater. 3 feet wouldn't mess with my house either, but that would really mess up our water supply and our water costs and our economy from that. Think of what it would do to like our wastewater treatment facility. The cost of wastewater treatment, if we had to actually pump water against gravity to get it into the ocean.
That's only if it rises like 30 feet, though, right?
Well, I don't know. I don't think that plumbing is much more than a few feet above sea level. Here's another one. I think everybody has noticed that if we get a high tide during a severe storm, we're already getting water somewhere along that boardwalk near Cabrillo, right? If you could raise that storm surge by 3 feet, I'll bet you that would be the funk zone. I'll bet you that would be some City College parking.
I wouldn't be able to skate.
Yeah, it would be a skate park. The storm potential for just a few feet is pretty significant. And here's the number that really blows minds for students. 1/3 of our species lives within 300 feet of sea level. 1 in 3 living humans today would have those peripheral issues. So they might not get their feet wet either. But what happens to their waste disposal? What happens to their coastlines? Does everybody realize that almost every major city in the world is on the ocean? Because the major cities were picked at a time when transportation was seagoing. Everybody knows that, right? So you pick your global capitals, they're all coastal. That's how they became global capitals, by definition.
Madrid.
And so if you've got most of the big cities dealing with this gradual retreat, you know, like think about how many people live in that flood zone that I just mentioned for the storm surge only. They still got to move. Think about the cost of moving like the railroad. Think about every major city in the world having to move all of their harbors. Like Long Beach Harbor and Los Angeles, all those harbors have to move. It's not like a disaster of flooding. It is a disaster of infrastructure. Did anybody remember Hurricane Sandy hitting New York City like 2 years ago, was it? All that was a more severe than usual storm that came during a high tide period after New York had experienced whatever it is, 1.7 inches of sea level rise. And Wall Street got shut down for 3 days. Reconstruction cost, what, $60 billion, $65 billion in New York City?
The subways flood too.
They did, yeah, shut down the subways. This is what I mean. It doesn't take a lot of water rise because we all live pretty close to the ocean. And it's the infrastructure that goes downhill. My kids always complain when they built like a fort in the living room, and I'm like, come on kids, it's time to clean up for dinner. They're like, oh, Dad, I don't want to take it down. I don't want to rebuild it tomorrow. It's too much work. I'm like, that's 2 sofa cushions and a freaking blanket. Like, I keep thinking about like moving our fort. Like, that's burly. Number 7. Anybody remember what happens when you mix oxides and water? Very good. I'm glad you remembered. Now look at this. Oxides and water. Our ocean is becoming acidic. And everybody was freaked out about temperature gain in the ocean, and then we realized that acidification is much more deadly. The amount of CO2 that we put in the planet is enough to warm the ocean, like, okay, the ocean's hotter. But it's made the ocean more acidic, and apparently that acidification is really severe. For most species, temperature range is give or take 5 degrees, give or take 10 degrees for short periods of time. For most species, pH tolerance is 1/100th of a point. If I change your bloodstream pH by 3/100ths, you die. Doesn't take a lot of acid or base to do that. You've got this like extremely complex metabolism to keep your blood pH regulated very carefully. The ocean is changing by factors far greater than that. If your blood had changed pH by as much as the ocean has changed, you would have died a long time ago. Number 8. With the hot and the cold and the wind moving around, currents will change. And that's kind of a wild card, because who knows, maybe the currents will benefit us. Like maybe the salmon will come through the channel and I'll be stoked. But those changing currents could also be very destabilizing food supply and trade relationships. Imagine international trade in that scenario. Like what if it got too expensive for us to use China's factories? What would that mean for our economy? What would that mean for China's economy? The current thing is kind of serious. Number 9, you might remember from Unit 6 that the severity of hurricanes will go up. It's not that the number of hurricanes will change, it's that their severity will change. More of them will be the bad ones.
that have to go for like all tropical storms too? Or all kind of like
Well,
patterns?
tropical storms include a severe category we call hurricanes. And hurricanes include a subcategory that are especially severe called Cat 4 and 5. More of total tropical storms will be on the severe side, and thus more of the hurricanes will populate the category 4 and 5 that we really worry about hitting land. Now I'd like you, for number 10, please look at 1 through 9 and make a little mark like a bullet or a star or a circle or an underline for the ones that might hurt an economy. That's right. All of them. You know, our economy gets really destabilized when, like, Apple shareholder meeting is kind of grumpy that Tim Cook hasn't bought Tesla yet. And the global economy falls through the floor for 5 to 6 years when a couple of banks do some funny shenanigans about how they package debt. Imagine what happens to the global economy when 1 through 9 all happen in the same century. Like, you might do really well selling coffins or something. There's probably some economic opportunity to be had here. But I think it's safe to say that economies will destabilize. Even if they're going to have some winners, they're going to have a lot of losers. And then for number 11, look through 1 to 10. How many of those would force a struggling poor person to move from their homes? All of them. So number 11 is a new term. They're called environmental refugees. In the coming century, more people will move because of climate than have ever moved for any reason combined. I want to try to say that again. Environmental refugees in this century will outnumber all refugees of all centuries. If you go to refugeeism from like Genghis Khan and the Greeks and the Romans and World War I and World War II and Vietnam, this will be worse all in the same century. Because keep in mind, there's a lot of people who are just barely getting by. When the river dries up, they got to move. When the corn fails, they got to move. When sea level rises, they got to move. When the diseases start killing the babies, they got to move. We have a lot more people that are living what you might call a marginal existence than we ever have, and then we're going to scramble their eggs more than they've ever been scrambled. So environmental refugees, 150 million is a safe estimate for this century.
Oh.
I mean, if you think you're smarter than everybody else, go for it. But the UN is preparing for this. The U.S. military is preparing for this. Berkshire Hathaway is preparing for this. These numbers are relatively conservative. I'm keeping it safe with everything I've said today. I don't want to get in trouble because your mommy and daddy are in some fancy think tank. I've just said the stuff that I think is pretty indisputable. So should we all go run out in traffic?
Yes.
Well, we're in America.
Do we all mix up a bunch of Kool-Aid?
Go Jonestown.
Should we all go Jonestown? I think Better's just like, she saw where this was going. Not really, we're America.
We're like the last one for the
Yeah, so like one way to look at this, for better or for worse, we're probably not the ones that'll die first. I don't know if you should feel good about that or bad about that. Like, yeah, it might make you think. It might make you feel differently about your like fancy international wardrobe or like your conflict zone resources. I mean, remember, you know, like, it may not even be your problem. Remember also that in the geologic time scale, who cares? There is nothing we can do to climate that cannot heal within roughly 7,000 to 12,000 years.
Nah, we can do it.
People have argued, aside from setting off all the nuclear bombs at the same time, which would, by the way, pulverize the planet 3 times over. We'd have enough nuclear bombs on Earth to pulverize 3 Earths. If they were all, if they were set off at the same time, which is mechanically pretty difficult. But. Aside from really extreme comedic exaggerations, the Earth will be fine. The age of like the flying jellyfish will be beautiful. I think that the real question is like, what's the next century going to be like? And every time I hear people talk about climate change as a problem for the future, I'm like, no, bro, past tense, me and you. And every time I hear people say, we can't worry about the environment, I got to worry about the economy, I'm like, no, other way around. Other way around. Because like, it's like looking at that big old savings account, like, I can't worry about putting money in there, I just got to take the money out. And I'm like, no, remember, you can't take the money out. So everybody's like, oh, who cares about global sustainability, I just got to get some seafood. And it's like, no, other way around. But it, like, it's a fairly compelling case. I think that pretty soon, people your generation aren't going to like deal out with this one. No. And before you all leave, I've got a couple of numbers and a couple of facts for number 25. I know everybody packed up, but that's too bad. I will use my last 3 minutes come hell or high water. Number 25, your book was wrong.
Oh.
Yeah, the planet has warmed up 1.8 degrees Fahrenheit in the last century.
Oh, is it 0.5? Oh, 0.9.
It said 0.5 Celsius, 1 Fahrenheit. It's actually 0.9 Celsius, 1.8 Fahrenheit. Your book was wrong. It's actually 0.9 Celsius, 1.8 Fahrenheit. Technically, the United States, because we're in the northern hemisphere, we warmed up more than that. We warmed up 2 degrees Fahrenheit. In the last 50 years alone, actually.
Wait, so is this increase over the last, is our book said over the last few decades, or is this over the last century?
That's actually centurial. The 1.8 is 1 century. But in the United States, we've done 2 degrees in just 50 years. To be more, put a finer point on it. Rain is up 5% in the United States, but it's gone steeply downhill in the Southwest. That's what I mean about destabilizing weather. Some places wetter, some drier, but no place the same. Big storms are up by 20% nationwide. We have seen more and worse of the heavy hurricanes. And there are solutions. Stanford University wrote a really famous paper you got to know the name of. It was called the 15 Wedges paper. Not wedgies, wedges. And they said, look, global temperature is going to do this. And no, there is no way to keep it flat. But they argued, what if we just took little slices out of it? The 15 wedges. Their idea was, what if we made more solar panels, more wind turbines, more natural gas, more home efficiency, more electric cars, more this, more that. They got 15 wedges that add up to keeping it stable. It's called the 15 wedges concept. And you've got to know the name because that's a famous one. You don't need to know what the wedges were. You've probably heard every one of the wedges. And I've got some kooky ideas to change the planet in case anybody here is curious. We can paint cities white. If we take the 10 biggest cities and we paint them white, we cancel out a year's worth of temperature gain. Here's another one. Let me finish this real quick. I've mentioned this before. If we merely provide free condoms to people who want them and can't get them, that's the cheapest conversion of dollars to reduce greenhouse emissions.
Nice.
We can shoot trash into space and make a cloud of dimming global dust. It's called global dimming. We can fertilize the ocean and make more algae. Apparently they just need iron. Bye, students.
Great ideas.
Oh, dude, I seen you something. What?